All right, in this video, we're going to end up graphing our tangent graph accurately. Okay, we want to base this off of some of our unit circle values and find the exact values and then find the decimal values so we can plot them and see what a tangent graph looks like. Okay, so we know that tangent of theta is usually opposite over adjacent. Okay, but on the unit circle, if we go back to our unit circle, when we drew these triangles, the opposite side was always the vertical side, the y-coordinate, and the adjacent side was always that horizontal side, the x-coordinate. Okay, so we had the y-coordinate on the unit circle over the x, which is our sine of theta over the cosine of theta. Remember, the x and y coordinates were cosine and sine. Okay, so sine over cosine. All right, so looking back here, we want to look back at each of these values and take from the unit circle the y-coordinate over the x. If we look at 0 degrees, okay, over here, the y over the x would be 0 over 1. Okay, so we're going to put 0 over 1. Oops, 1. Whenever we have 0 divided by a number, that's just equal to 0. Okay. It's when we have it the other way around. We're not dividing by 0 here. 0 is going to be on the top of the fraction. This is going to equal 0. When I go to 30, okay, root 3 over 2 comma 1/2, we're going to take the y divided by the x. So 1/2 over root 3 over 2. When we have a fraction divided by a fraction, we need to simplify that sum. So when we divide by a fraction, we're multiplying by the reciprocal. But which one do we flip? We're taking 1/2 and we're dividing by root 3 over 2, so we'll multiply by 2 over root 3. Okay, so that guy equals this equals, we can see some simplification, the 2's cancel, we just get 1 over root 3. Okay, don't forget the 1 over part. The 2's cancel and they're gone, but there's still a 1 on top, and the root 3 is still on the bottom of the fraction. Okay, moving on at 45, we've got two of the exact same x and y coordinates. They're the same. It's 1 over root 2 and 1 over root 2. So when I divide those, whenever you get the same number over itself, it's always equal to just 1. Okay? It's like 5 over 5, 7 over 7, pi over pi. It's just equal to 1. At 60, we've got 1/2 comma root 3 over 2. So the root 3 over 2 is our y coordinate. The 1/2 is our x. That's root 3 over 2 times 2 over 1. Remember, we're dividing by a half, so we're multiplying by 2. Cancel, cancel, I just get root 3. Technically, it's root 3 over 1, but any number over 1 is that number. Okay, we don't have to divide by 1. And lastly, tangent of 90. At 90 degrees, I'm up here at 0, comma 1, right? So I take the y over the x, and that's going to be 1 over 0. This, when we're dividing by 0, is undefined. Okay? So an undefined value is whenever you're dividing by 0, you're definitely going to have something undefined. You can't divide by 0. Just mathematically impossible. So to approximate these, I know 0 is 0. I know 1 is 1. This is undefined. Okay? These other ones, the 1 over root 3 and the root 3, we have to simplify in our calculators. We have to evaluate in our calculators. This is going to be between 0 and 1. This is 0.577. 10 to 60, root 3 is 1.732. So we'll use those numbers when we start plotting the points. Okay? But before I do that, I want to fill in this whole table right here, all the way from 0 to 360 with all of the unit circle values, because that will help me plot more points when I actually go to actually draw the graph. All right, so 0, 1 over root 3, 1, root 3, and then at 90 we had it being undefined. I'm going to use a U here for undefined. Okay. As we keep going, what you'll notice is we'll still get these same numbers, but maybe some negatives, because as we keep going around the unit circle, we'll see some more negative values. So for example, at 120, I get this point, but it's basically the same as this point. It's the same x and y coordinates, only this one's negative. It has 120 has a reference angle of 60, so that's why it's like 60 degrees, but it just has an x value that's negative. So at 120, I'm going to look at tangent of 60, but I'm going to realize that this x-coordinate down here is going to be negative now. So if I have a positive over a negative of that same thing, I'm still going to get root 3, but I'm going to get negative root 3. And at 135, I have a reference angle that's 45 degrees. Again, the x-coordinate is going to be negative, so I'm going to get negative 1. For 150, his reference angle is 30 degrees. It's the same ratio, only this one is negative, so I'm going to get negative 1 over root 3. And as far as I go back to 180, I'm going to have the same angle or same ratio here, only at 0 over negative 1. But 0 over negative 1 is still 0. Okay. So as we keep going, now to the third quadrant, down here at 210, both of these are going to have negative values. Both the x and y coordinates are going to be negative. So at 210, my reference is 30. Reference angle is 30. But now both of these here are negative. So if I have a negative over a negative, that's going to cancel each other out and be positive. So this will be positive 1 over root 3. Okay, and as I keep going, 225 has a 45 reference. It's a negative over a negative of the same number. It's going to end up being positive 1 again. Okay, and this one's going to be positive root 3. And at 270, I'm going to get negative 1 over 0. It's still undefined. Okay, so as I keep going here, you'll see this pattern continues. 300 has a 60-degree reference. Only the y-coordinate's negative now, so it's going to be negative 1 over root 3. Oops, sorry. 60-degree reference. Right over here, it's going to be negative root 3. And then 45-degree reference, but one of them's negative. Okay, so I get negative 1. At 330, I have a 30-degree reference. Only the y is negative. I'm going to get negative 1 over root 3. And now I'm back to 360. That's the exact same location. It's coterminal with 0 degrees. I'm going to get 0 again. So now we have some points that we can actually plot on our graph. Okay. So I'm going to take these and I'm going to plot these points. 0, 0. Okay. 30, we said that's 0.577. So right there-ish. 45 and 1. Okay. 60 and 1.7 something. Right there. At 90, we're undefined, so there's no point on the graph there. When you're undefined, you have no value for the function. So I can't plot anything at 90 yet. At 120, I'm going to be negative 1.7-ish. 135, I'm going to be negative 1. 150, I'm going to be 0.57-ish right there. All right, so I've got some so far. 180 is going to be 0. I'm going to pause here and let you finish this up. You can pause and finish plotting all these. All right, now that I've got all the points plotted, as you can see here, we're going to move on to the next step. We didn't plot any points when we were undefined, but it says tangent has places where it's undefined because you're dividing by 0. In these places, it has vertical asymptotes. So when we draw vertical asymptotes on our graph, we draw them as dotted lines. Okay, any asymptotes are going to be dotted lines. So these are going to be vertical dotted lines. We were undefined at 90 and 270. So at 90, I've got an asymptote. Okay, and 270 is going to have a vertical asymptote too. Okay, so check. We got that done. Now, we can connect the points with a smooth curve. We know that when we have an asymptote, our function gets closer and closer to it, but just never ends up touching it. Okay, so as I go through here, I'm going to try and connect these with a smooth curve. Looks like it's increasing and concave up, and then the closer I get in the x direction to that asymptote, the closer, I'm going to get really, really close to that asymptote, but I'm never going to cross through it. So this end is going to go up to infinity, right? Toward the y-coordinates go toward positive infinity, bigger and bigger and bigger, steeper and steeper. As I come this way, right, connect the dots up this way, oops, almost missed that point, asymptotic down that way. It's kind of easier to go toward the asymptote than to start and come away from the asymptote. So I try and draw all of my curve pieces toward those asymptotes. Okay, so we can definitely see some different pieces. Some places here are concave up. Some places here are concave down. Okay, but if you notice, everywhere along here, this function is increasing. Okay, it's increasing, picks up its pencil at the asymptote, starts over and increases again, picks up its pencil, starts over, increases again and again and again. Okay, so connected the dots. Awesome. What is the period here? How long does it take to go through one full cycle? Do I need the whole graph here to repeat itself, or does it repeat earlier? Well, if you look, I can take this whole chunk right here and this whole chunk right here, and if I pick that up, can I pick both of them up? Oh, it doesn't group these guys together. Now I can make them group together. Hey, that one too. All right. Oh, okay, so it won't do that. Anyway, so if I have these two blue pieces together, if I pick them both up and slide them over, okay, both of those two pieces make another piece of the graph right there. So really, the period here, I don't need all from 0 to 360. Even in the table, you could see from here to here, it starts repeating the same values right again, right there again. So it only needs 180 degrees to start repeating itself. Okay, the period is 180 degrees now. That's a lot less than the sines and cosines, which were 360. Okay. Lastly, our last problem here, we see that we want to find where all of the vertical asymptotes are, right? Not just the ones shown. The ones I can see are at 90 and 270, but there's more, right? Because you can keep going farther in the positive direction, you can keep going farther negative, but we just didn't draw that because we didn't want to draw so much of the graph, right? But it keeps continuing on. So these are going to be 180 apart. Since the period's 180, it keeps repeating the same graph every 180 degrees. So if I add another 180 onto this, okay, I'm going to be at 450. Okay, if I add another 180 onto this, I'm going to be at 630. Right? There's more. Keep going this way. There's going to be some negative ones at negative 90 and negative 270, and etc. back that way. We don't want a whole list like this. Like this isn't enough. Okay? If we want an equation for all of the vertical asymptotes, we need to write it like this. Theta equals. I see my first asymptote at 90 degrees. And then I can keep adding multiples of 180. I can add 180 once or twice or 3 times, or you can even subtract 180 once or twice or 3 times or 4 times or 5 times to get more of the asymptotes. So I want plus 180 times n, where n is any integer. Okay, an integer, for those who might not know, is like all of your whole numbers you like to work with, like 0, 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. But it also includes the negative version, so negative 1 and negative 2 and negative 3. So if I put in n equals 0, then I'm going to end up with 90 plus 180 times 0 is 90. If I put in n equals 1, I'd be here. If I put in n equals 2, I'd be here. n equals 3. How many of those 180s have I added? Or if I put in a negative value, then you're adding negative versions of 180, right? So you're subtracting 180, okay? So you can go farther that way. That will find you any asymptote, because if you put in different values for n, any integer for n, you'll find another asymptote.